Hello and welcome to today's science lesson. So first of all, guys, can we all turn to wave and say a big hello to our friends on camera? Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps and close our eyes. When you're ready, guys, you can open your eyes and come back to the room. Excellent. And next we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then let's go down low. Touch our toes. And then back up high one more time. And this time, can we go tippy toe high? And while we're there, let's have a wave side to side. And then back down to touch our toes again. Now we can do some rotations. So we'll go left, right, left, right, left, right, left, right, left, right. Excellent, guys. And now, time for some stretches. Let's do 5 stretches to our right. 1, 2, 3, 4, 5. And then 5 stretches to our left. 1, 2, 3, 4, 5. Excellent, guys. Shake it out. Arms and legs, shake it out. And then we can take our right hand and find our left foot. Left hand, right foot. Right hand, left foot. Left hand, right foot. Right hand, left foot. Left hand, right foot. And to finish, guys, we will do 5 claps. 1, 2, 3, 4, 5. Brilliant, guys. Have a seat. So in our previous science lesson, we began learning about a new topic. And the name of that topic is something that keeps us on the ground, near the earth. Does anybody remember the name we give to the invisible force? Gravity. Excellent, Prel. Yes, there is an invisible force known as gravity that keeps everything on earth close to the ground. So let's write that word first. Gravity, G-R-A-V-I-T-Y. Gravity. And what we were learning about in the previous lesson is a longer term gravitational Yes, gravitational force. F-O-R-C-E. So altogether, guys, gravity and gravitational force. So if I say the word gravity to you, what do you think of? Can we see gravity? No. So gravity is invisible. The words we give to things that are there but we can't see, invisible. Yes, we know gravity is here. How do we know gravity is here now? What happens with this pen if I throw it into the air? It comes back down. You see? That's what we mean by gravity. If there was no gravity and there was no gravitational force, we would be like in space. Have you ever seen some of the pictures of the men who go to space in their special suits? And they're all floating around in the air. Does anybody know why they're floating in the air? What is there none of in space? Gravity. In space, there is no gravity. So things will just float around in the air. Space has no gravity or gravitational force. For example, where are you guys now? School. What are you doing? Learning. What are you doing? Sitting. If there was no gravity, you wouldn't be able to sit. You would be floating on the ceiling. You would be keeping yourself on the ceiling. And that's what we mean by gravitational force. We can't see it. It's invisible. We can't touch it. We can't even really feel it because gravity is something that works on us rather than us working on gravity. But rest assured, it's here, because if it was not here, everything in our classroom would be floating in the air. And what we're going to be doing in today's lesson is a practical demonstration. We want all of our students to choose one object, one different object each, and come to the front of class and then demonstrate how gravitational force has an effect on all objects. But before then, guys, we've got our PowerPoint presentation. So what we want now is our students to turn their chairs to the TV screen and listen, observe, and practice speaking about gravity and gravitational force. So let's turn to look at the TV screen, please, guys. And now let's take a look at our PowerPoint presentation about what is gravitational force. Yes, well, the simple answer, gravitational force is the thing that keeps everything on Earth. Now you can see in the picture here, what can you see here? Planet Earth, correct. And then notice how you can see all of these arrows pointing to the Earth. These arrows aren't really there. This is the gravitational force that's invisible. But what these arrows signify is that there is an invisible force that pushes everything back to the Earth. That's why when we throw objects up, they come back down. The invisible force is known as gravitational force. And that's what we're going to be learning about more today and demonstrating ourselves. When we jump into the air, we will always fall back to the ground. Always. Every time you play with your friends or you play sport, if you have to jump into the air, after a second or so, you come back down. Gravitational force. If we throw a ball into the air, it will go up and then fall back down to the ground. Same as when we jump. If we throw a ball into the air or anything else, after it stops going up, it will start to come down. And that is when the gravitational force is pulling it back to the earth. If we did it in space, if we had a ball in space and we throw the ball into the air, the ball would keep going in space. It would keep going up because there's no gravity. But on Earth, the ball stops going up and comes back to the ground because on Earth we have gravitational force. This is because there is a non-contact, invisible force acting on them. Now, by non-contact, what we mean is, if you reach out, can you feel gravity? You can't touch anything. There's nothing there. It's non-contact. Can we see it? No. So when something's there that we can't see, invisible, but we know it's there. Gravitational force. And remember, in the previous lesson, I told you the story about the guy who found out gravity. This man's name, Sir Isaac Newton. One day, a long time ago, he was sitting under a tree. And then what happened was an apple fell from the tree. And the man thought to himself, why did the apple fall down when it fell out the tree? Why didn't the apple fall up? Because, excellent. When an apple falls from the tree, the reason it doesn't go up, it comes down, is because gravity or gravitational force. Our Earth has gravitational force. This force holds everything close to the ground. Yes. Trees, water, buildings, and animals are all held on Earth by gravitational force. Yes. Look at the picture here. Look at the picture and see how everybody is playing in the park. Is everybody in the air? No. Where is everybody? On the floor, down on the floor, correct. And the reason that everybody is on the floor is because of gravity. What can you see here? Dog. The dog is on the ground because of gravity. What can you see here? A girl. Where is the girl? Walking on the ground because of gravity. And what are these pretty things here? Where are they? On the ground because of gravity. Even the things that are on water. Here, what can you see? A boat. Where is the boat? On the water. Not so much on the ground because it's on the water, but it's still down below because of gravity. Things that are on water are still controlled by gravity. So notice everything on the floor because of gravity. Even this boy, where is he now? Playing on the slide. Soon he will slide. Will he go up or will he go down? Because of gravity. Yes, he will go down. If there was no gravity, he would go up into the air, like in space. But because we have gravity on Earth, the boy will go down. You can see his friends now going down on the slide. Gravitational force pulls everything towards the center of the Earth. Yes. If there was no floor, we would keep going towards the center of the Earth. If there was a big hole in our classroom and we fall into it, we'd fall down because we'd keep traveling towards the center of the Earth. The high jumper jumps into the air. The gravitational force will pull her down. Yes. Has anybody ever done this? High jump. Okay. High jump, what happens is, you see this pole here? The competition is to jump over the pole. And you can see here the woman is trying to jump over, but once she gets across, will she go up or down? She will go down. Correct. Gravitational force brings her down. The basketball player jumps and throws the ball into the air. Gravitational force pulls them back to the ground. Yes. You see here, this basketball player, the one in red, is jumping and he's about to throw the ball. He's jumping up and the ball will go up. But in a few seconds, what will happen? He'll go down. Perfect. Because gravitational force brings both the person and the ball back to the ground. But remember earlier, I said about space, no gravity. If there is no gravitational force, all objects on Earth would be floating around, similar to outer space. Yes. You see this picture here? Does anybody know who this is? What name do we give to people who travel to outer space? Astronaut. Yes, the people who go in the spaceship. And because they're in outer space, no oxygen. They have to wear a special suit. But notice how, are they on the ground? No, because no gravity. They'll just be floating in space. And they have to wear a special rope or harness. For when they want to go back to the spaceship, they have to pull their harness. If they didn't have the harness to pull, they would carry on floating forever. Because in space, no gravity. Any questions, guys? That was brilliant. Very well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation so that they can review and learn some more facts about gravity and gravitational force, and in particular, the effects that gravity has on all objects on planet Earth by pulling them back to the center. And what we've got coming up now is a demonstration whereby our students will choose an object each to throw into the air in the classroom and show how the object will come back to Earth after a short while. So what we want your students to do now is spend the next 10 minutes selecting their own classroom object, or it can be an item of clothing, it can be anything at all, as long as it's not breakable. Because what we want our students to do is to come forward and throw it into the air, and then after a short while, when it comes down, to catch it again. And this will demonstrate the effect of gravitational force on various objects. So you can pause the video now, and in your own classroom, have each student select a different item. And remember, it can be a ball, it can be paper, it can be clothing, but make sure it's something that is not dangerous and cannot break. But if our students all choose something different, it will show the different effects. So pause the video now, and then we'll see you back in the classroom in 10 minutes, ready for the visual demonstration. Welcome back to class. So we hope that now all of your students have selected their own safe object, that they will demonstrate the effect of gravitational force in the classroom. But before then, guys, it's time for our stretch sequence. So let's stand up and push in our chairs. And for this sequence, we'll have a game of Teacher Says. So listen carefully. If teacher says, we can do. If teacher doesn't say, don't do. Okay? So teacher says, hands in the air. Teacher says, hands in the air. Hands down. Teacher says, hands down. Teacher says, jogging on the spot. Teacher says, hands in the air. Teacher says, wave them side to side. Teacher says, forwards and backwards. And stop. Teacher says, stop. Teacher says, arms by your sides. Teacher says, turn around. Back the other way. Teacher never said, teacher says, back the other way. Very good. Arms in the air. Teacher says arms in the air. Teacher says hands on head. Teacher says raise your right leg. Teacher says swap legs. Teacher says swap legs. Arms down. Teacher says stand up straight. Arms down. Teacher says arms down. Teacher says arms down. And teacher says down into a little ball. 5, 4, 3, 2, 1. Teacher says jump. Excellent, guys. And teacher says please sit down. And now, after our students have chosen their objects for the practical demonstration, we need to arrange them at the front of class like this. And before we invite our students to come forward, we need to complete the table on the board. So our table will have 3 different sections. The first section is the name of our student. So student is spelled S-T-U-D-E-N-T. And then we're asking each student to choose a different object. So we will need the name of the object in the second section, O-B-J-E-C-T. And what we'll be looking for is to see what happens to each object. We're expecting them to all come down, but will they come down quickly or slowly? So what we need to record in the final section is observations. All together, guys, we have student, object, and observations. Okay, so we've got our 3 sections on our table. And what we need now is we need our first student to come forward and demonstrate the object they have chosen. So our first student is Pangpon. So Pangpon, come and join me at the front of class, please. So first thing we need to do is the name of the student. What, Pangpon, what's your name? Pangpon. How do we spell, guys? P-A-N-G-P-O-N. Okay, now what is the object that Pangpon has chosen to demonstrate? Balloon. Okay, so Pangpon, balloon. Now, can you take hold of the balloon, please, Pangpon? And when you're ready, I want you to throw it into the air and then see when it comes down if you can catch it again. Okay? So throw it as high as you can. Catch it. One more time, higher. Okay, now can you catch it? So, observations. Did the balloon go up? Yes, it did. And then what happened? Quickly or slowly? Slowly. Came down slowly, I thought so. So we can say balloon comes down slowly. Okay. And now we move on to our next student. But Pangpon, I will ask you to stay here because the final time, after all of our students have done it, they will do it together. So now our second student, Lakgao. Lakgao, come and join me at the front, please. So now it's time for our student Lakgao. L-A-K-G-O-W. And Lakgao, what object have you chosen? A bottle. Okay. So B-O-T-T-L-E. Now Lakgao, can you take your bottle in your hand? And when you're ready, can you throw the bottle into the air and then try to catch it again? Okay, now one more time in front of the camera. Okay, so what happened to Lakgao's bottle? Did it go up? Yes. Then it came down? Yes. Did it come down slowly or quickly? Quickly. A little bit too quickly for Lakgao. Okay, so we can say the bottle comes down, not slowly, quickly. Okay, so now onto our next objects. Now this one will be very interesting. So Dan, come and join me at the front of class. Okay, now what Dan has chosen, first of all, Dan's name, chosen to demonstrate, Dan, bubbles. Okay, so this should be very interesting. Bubbles. Okay, so can you take hold of your bubbles? Can you open your bubbles? Oh, I might need to use the tissue here. Okay, now if you can, try and blow them up into the air. High as you can. And again, try again. Put them back in. Okay, and then blow. Excellent. Now blow up. Do it one more time, and this time blow up into the air. Hold them high. There you go. Okay, so watch the bubbles. Where are they going? Going up. And then, after a while, where are they going? They're coming down. Or some of them are coming down quicker than others. Okay, so observation. So, did the bubbles go up? Yes. And then did they come down? Yes. Quickly or slowly? Slowly. Slowly. Okay, so bubbles we will just put come down slowly. And that's 3 students. And now, on to our next student, Prel. Come and join me at the front of class, please. Okay, so keep hold of your things, guys, because at the end we're going to do it all together. So Prel. P-R-A-E-W. What object have you chosen? Whose hat? Teacher's hat. This is my hat because the weather is cold, so we're wearing our winter clothes. So let's say hat. And when you're ready, you can throw it up into the air and then try to catch it. Excellent. One more time. Up into the air, and then what happened? Came down slowly or quickly? I think it came down quickly. Okay, so let me write quickly. So you notice how everything is coming down, but coming down at separate rates. Now, Nadia, your turn. Come and join me at the front of class. So Nadia. N-A-D-E-E-R. Now, Nadia, what object have you chosen? You have chosen a marker. Okay, so Nadia, you take hold of this marker for me, and can you throw it into the air? Stand here and have a look at the camera. Nadia, you can throw up and then try to catch it. Excellent. One more time. Perfect. So Nadia, with the marker. Now, what was our observation? Did the marker go up? Did it come down? Slowly or quickly? I think quickly too, yes. Okay, so quickly. So now we've got 2 students left. Pak Bung, can you come and join me at the front of class? So Pak Bung. Can you show me your object, please? What? A tomato. Is it a real tomato? No, it's a toy tomato. Okay, so tomato. Now, when you're ready, you can stand here, the front, and throw your tomato into the air. And can you catch it? Excellent. One more time. Up into the air. Observations. Did the tomato go up? Did it come back down? Slowly or quickly? Slowly? Really? Quickly. I think quickly. Yes, I think quickly. Okay, and now for our final student, Net. Come and join me at the front of class. Okay, so Net, what is your object? Paper ball. You have a paper ball, okay? So paper ball. Now, Net, when you're ready, can you throw your paper ball into the air and catch it? Excellent. One more time. Paper ball. What happened? Did it go up? Yes. Did it come down? Yes. Slowly or quickly? Quickly. Quickly. But watch what happens when we have some softer paper. This is a piece of paper known as tissue. Now, if we throw tissue into the air, because it's not as heavy, it will come down. But did it come down slowly or quickly? Slowly. Yes. So what I'm going to ask my students to do now is to all stand in a line. Get your objects ready one more time. Let go. Are you ready with your bottle? Ready? Everybody ready? What I want to do this time, everybody throw them together and then catch them. So Dan, are you ready with your balloons? Hey, Bubbles. Ready? 3, 2, 1, go! Excellent. Balloon. Excellent, guys. Well done. Welcome back to class. So after the fun of our practical activity that demonstrates how gravitational effect pulls everything back to Earth, it's now time for our students to complete their worksheets. So teachers, make sure every student gets their own worksheet. And what we've got is a table similar to the one that we have on our board. What our students need to do is complete their worksheet to show the information that we did with the practical activity. The student's name, the name of the object, and then our observations. Did the object come down slowly or did the object come down quickly? So now, give our students around 12 minutes for this activity and just help them with anything you need. So, Bangpon, this one's for you. You're welcome. Let go, here's yours. Down, this one's for you. You're welcome. Preo, here's yours. You're welcome. Pakbong, here's yours. And Net, finally, for you. So names on top first, guys, and then record the observations and the results of our practical demonstration. First of all, the name of our students, and then the objects that our students chose to demonstrate. And then finally, did the object come down? And if so, did it come down slowly or quickly? And at the end, we have 2 questions for our students to answer. So the first student was Bangpon, and Bangpon's object was a balloon. And the observations was the balloon comes down, but slowly. Because a balloon is filled with air, it will come down slowly. The second student was Lakao had a plastic bottle, and the plastic bottle comes down quickly because it's not filled with air. So notice how different things will come down at different rates. And then when you're ready with the questions, guys, let me know. Because we need to find out what is your conclusion for this activity. Well done, Net. So you can see the bottle comes down slowly, or the bottle comes down quickly. And then down with her Bubbles. Did the bubbles come down quickly or slowly? Slowly, excellent. You can see the bubbles come down slowly. And then question 1, what is the conclusion to our activity? For question 1, the conclusion to our activity. Did everything that we throw into the air, did it all come down? Every single object that we chosen came down. So you can see the conclusion to the activity is that everything that goes up will come down because of gravity. Gravity pulls everything What is your conclusion for this activity? So question 1, our conclusion, Prao, everything that we threw into the air, did it come back down? Yes, so we can say gravity pulls everything back down or back to Earth. Yes, the floor, down, or Earth. But the key to remember is that on Earth we have gravity. If we're in space, no gravity. So on Earth, gravity pulls everything back to Earth. And then question number 2, what is your evidence? And question number 2, our evidence, everything came back down. In fact, we will say, all objects came back down. Every single object that we've thrown into the air came back down. Some of them came down slowly, and some of them came back down quickly. But the important point to remember, all objects went up and came down. And that's because of gravity. Just like with this marker pen, like Nadia did. We throw up, it comes back down. Welcome back to class. We hope your students enjoyed the worksheet exercise also, where we could record our findings for the practical activity. So remember, we have our students, the object, and then also our observations, whether they came down slowly or quickly. And that leads us to answer our final 2 questions. What is our conclusion for this activity? So all together, guys, gravity pulls everything back to Earth. And in question number 2, how do we know? What is our evidence? Well, we've seen everything come back down. So we can say all objects came back down. And they came down because of gravity or gravitational force. And that brings us to the end of today's lesson. And guys, that was brilliant. Some great demonstrations too. So like I said, that's the end of today's lesson, and we hope you've enjoyed it and our students have had the chance to find out about gravitational force for themselves. And we'll see you again soon for the next lesson. So can we turn to wave and say goodbye, guys? Goodbye. Bye-bye. See you again soon.